Hi, so today we are going to learn motion of a charge in any magnetic field. So when charge moves in a magnetic field, it is acted upon by a force called Lorentz force, and the force is given by equation F is equal to QVB, V cross B. So force is perpendicular to both velocity and magnetic field. And this is the force which is unlike electrostatic force. In electrostatic force, we can see that force is in the direction of electric field, and it is in the direction of change of velocity. So it produces momentum, it carries energy too. This force carry energy. Electrostatic force F, which is equal to Q into E. This force is acting in the direction of change of velocity of charge . So it produces a change in momentum, and so it carries energy. Whereas magnetic force, Lorentz force, which is equal to Q V cross B, here V is perpendicular to magnetic force, and in such kind of force we have seen that when velocity is perpendicular to any force, such kind of motion is along a circle. When velocity is along tangent direction at each and every point, velocity is along tangent direction in circular motion, uniform circular motion, we have observed that force is along center, and that force is called centripetal force. Now here your magnetic force is also perpendicular to velocity, so force will be always along center of the circular path, and the charge will move on a circular path. Now we also know from our beforehand information, knowledge, that in such kind of motion work done is zero, because we know that work is equal to F dot ds, force into displacement, and you can see that force and displacement are taking place at 90 degree, so it becomes equal to F ds cos 90, it becomes equal to 0. So in case of magnetic force, work done is equal to 0. It suggests that magnetic field carries no energy. It also does not carry momentum. It only can change the direction of momentum. As direction of velocity is changed, so direction of momentum is changed. Okay, let me take some space. So when let us write once again the formula of magnetic force. F is equal to QV cross B. Now when V and B are parallel to each other, one component of V and B are parallel, V will have two components. Suppose here you have magnetic field, and V is in a direction which is neither perpendicular nor parallel to magnetic field. So vector V will have two components, V along B and V along perpendicular direction, VB and V perpendicular. So this perpendicular component, due to this velocity, the particle will be doing circular path. But now for a component which is along magnetic field itself, the angle becomes 0 and sine of 0 becomes 0. Therefore V into B, force magnetic along B direction, along the direction of magnetic field, is equal to QVB into sine 0 degree, and this is 0. So you have two forces. If you have velocity which is not perpendicular to magnetic field, and either it is not parallel to magnetic field, then the velocity will have, we can take two components of velocity, one perpendicular velocity and force on the charge. For this perpendicular component of velocity will induce a circular path, but the component which is along B itself, magnetic field itself, due to that component, net force is equal to 0. And we know from Newton's first law, when net force acting on a body is 0, then the body will remain moving with uniform velocity until and unless any force is applied on it. So a charge which is at some angle theta with magnetic field, it will have two components, one perpendicular component, one parallel component. Due to perpendicular component, the path executed by charge will be like a circle, and due to this parallel component, when net force is equal to 0, then the charge will remain moving until unless any external force is applied in this very direction. So on the same particle, on the same charge, there will be acting two kind of velocities, one perpendicular and one parallel to magnetic field. The parallel component will try to produce charge along the direction of B with equal speed. So and perpendicular component will execute a circle, and parallel component, due to parallel component, it will remain moving with uniform velocity VB. So instead of getting a circular path, we get a path of the shape of a spring, which is called helical path. So we see that a charged particle, when moves in any magnetic field, it can have two kind of paths. One, a circular path, when velocity and magnetic field are at 90 degree, then this is first case, then path is circular, and when velocity and V and B are not at 90 degree, then the path is helical. Now you would have heard about aurora. It is a very beautiful display of light in two regions of our Earth, one in Alaska, one in along Greenland. Actually, what happens when solar radiations gives out electrons, charges, radiations from sun? This is when radiation from sun and it reaches to Earth's atmosphere in Earth's magnetic field, it is carrying sun flares carrying electrons, which are charges, and Earth has magnetic field. So as soon as charges reaches in Earth's magnetic field, its velocity is not at 90 degree with the direction of magnetic field. So the charge starts executing a path of the shape of helix. So here is the path of helix for one charge. For another charge, here is a helical path, and all the charges when reach close to each other, they agitate with the particles of atmosphere. These charges agitate with the particles of nitrogen and oxygen. Okay. So while it is agitating with oxygen particles, a green display of light can be seen. And when it agitated with nitrogen particles, a beautiful display of pink light can be seen. So two phenomena happen. Atmosphere, okay. Magnetic field of Earth. Magnetic field of Earth. So there is green display of light. Due to agitation of charged particles with oxygen molecules. And when these charged particles moving along a helical path agitate with nitrogen molecules, they gave pink color. Pink, they gave display of dance of pink color. So this is all about what is the shape of path of a moving charge in magnetic field. It is your circular and it is helical too, due to a component of velocity of charge along magnetic field. Here you can see velocity has two components. This is the velocity and this is magnetic field. One component of velocity is along magnetic field and other component of velocity which is perpendicular to magnetic field. Now, motion of a charge in combined electric field and magnetic field. Suppose you have, as shown in diagram, electric field in this direction and magnetic field at the same very point is along z direction, you can see, and velocity of the particle is along x-axis. So from either right hand thumb rule or screw rule, you can find the direction of magnetic force. Force is equal to q v cross b. So starting from first vector, if you go to another vector, you find the direction of the vector product of the two, that is force magnetic, is along negative y-axis. This is your negative y-axis. So the two forces, in a particular case, when sum of the two forces becomes 0, when the sum of the two forces electrostatic force due to electric field, and magnetic force due to magnetic field along z direction. A same charge here is present, moving with velocity v. Its velocity is along x-axis, but at this very point you have two fields. These fields are called cross fields. Electric field is also there, magnetic field is also there, and due to which the two forces are acting in opposite directions. The two forces due to electric field and magnetic force due to magnetic field are, if equal and opposite to, then force electrostatic, which is along positive y-axis, means plus j cap, and minus force magnetic, which is along, I have already given notation of vector, okay, force magnetic along minus j cap. If this becomes equal to 0, then we find that force electric is equal to force magnetic, and force electric, we know that Q into E is equal to force magnetic is equal to QV into V. I am writing only magnitude. And they are perpendicular. This velocity and B, you can see, are perpendicular. So sine 90 here, sine 90 degree means 1. Therefore, if you cancel Q, your velocity comes equal to E upon B. Okay. So if such forces are there, when net force is equal to 0, in that case, velocity of the particles must be equal to electric field by magnetic field. The magnitude of velocity can be taken in this way. Okay. And if you take a beam of charged particles, you have several charged particles, not a single one, several charged particles going with different speeds in any such kind of cross field. Then what happens? All those charges with velocity, this velocity which has ratio E by B, will be acting upon by zero force. So when no forces are acting, they will, from Newton's first law, when no forces are acting on a body, then body will remain moving with uniform velocity in inertial direction. So such charged particles will be collected along one direction, and all other charged particles will deviate from its path. So this kind of device is called actually velocity selectors. These devices are called velocity selectors. Once again I am telling that you have a beam of charged particles, moving charged particles, and they are moving, all the charged particles are moving with different velocities. So they will have some charged particles which is having this velocity, which has value magnitude equal to electric field by magnetic field. These charged particles will be collected, will go undeviated through this cross field, and rest of the charges with different velocities, they will be scattered in other directions, and here we can collect all those charged particles moving with same velocity. So the device are called velocity selectors, and for velocity selectors we use, for this we use cross fields. So this is one application of cross field. There is one more device, and that is called cyclotron. This is your cyclo usage cross fields. So a slide description of it. Here you have magnetic field coming out of the plane of this surface, and there are two Ds, D-shaped. Here you have a D-shaped container. You can. So we learned cross fields, and cross fields is used in so many devices. Here we have used a velocity selector, and second one is cyclotron. So we will be discussing how cyclotron works, what is the construction of a cyclotron. But before that, we must learn the principle on a cyclotron works, working principle. So we know that in a magnetic field, the charge executes a circular path, and the force is acting towards center, and velocity of the charge is towards tangent direction. This is also a kind of centripetal force. So when you equate centripetal force, with that of magnetic force, because centripetal force is provided by this magnetic force, because this force only is acting towards center. Then we find that force is equal to QVB, and since it is at 90 degree, so sine 90 is equal to 1, and this is equal to mv squared upon r. So therefore r is equal to mv upon qb. Larger the momentum, larger is the velocity, larger will be radius. But actually, this is not working principle. I am coming to working principle. Since we know that V is equal to R omega, now replacing V with this value in equation 1, we find that R is equal to M R omega upon QP. And we know that since omega is equal to 2 pi upon t, angle per unit time, therefore this equation becomes QB is equal to m 2 pi upon t, and therefore you find that time period is equal to 2 pi m upon qb. Here time period is independent of velocity. How fast the charge is moving or how slow the charge is moving, it will not affect the time period of one complete rotation. Time will not be affected. And this has a very useful, this is very useful in the context of cyclotron. And here you can see that frequency n is 1 upon time period, therefore frequency becomes equal to qb upon 2 pi m. So you can see that larger the mass, smaller is the frequency, and smaller the mass, larger will be frequency. So if you take an electron, then its frequency will be very high because mass will be very small. And this frequency will not match the frequency provided by electric field or electric current, because electric current has a certain frequency. In India it is only 50 Hz. We can increase frequency up to a certain value. So if we take mass of electron, then frequency will be very high. So in cyclotrons we take actually positive charges, protons, which is nearly 1800 times, 1840 times more massive than an electron. So therefore, in cyclotron, we do not take negative charges electron. In cyclotron, we use protons or other positive ions. So this is your working principle. Frequency or time period is independent of velocity. Of a cyclotron. frequency or time period is independent of velocity, but radius, from this equation you can see, radius is proportional to velocity. If velocity is increased, radius of circular path will be increased. So this is your working principle. Frequency or time period is independent of velocity and radius is proportional to velocity. Now you're in this very diagram. This is your cyclotron. Cyclotron is a device that is used to accelerate charged particles to a very high velocity. It only accelerates charged particles to high velocities, and these particles are used to bombard in your scientific observations, scientific any kind of work, to bombard any atom, to bombard any nucleus, to study the atom or nucleus. Now how it works, let me discuss with the help of diagram. Here you have cross field. Now magnetic field is coming out of this plane of paper. These dots of blue colors, these are used to show magnetic field. And in this magnetic field you have two D-shaped containers. As these are D-shaped, so they are called D1 and D2. They are two in number. And we know that a completely enclosed container, metallic container, acts as an electrostatic shielding. So if charge comes to this region, no electric force, let me tell again, no any electric force or electric field acts on the charge when charge enters in this D-shaped container. Note, in D1, D2, no electric force on charges. So force on charges are there in between the two Ds. Now these two D-shaped containers are connected to an electric oscillator with having very high frequency. These oscillators are actually work on alternating current with very high frequency. So you have cross fields, magnetic field coming outside and electric field which is perpendicular to the magnetic field in the plane of the paper. So when one more thing, resonance frequency. When the frequency of motion of charged particle becomes equal to frequency of AC oscillator, then such frequency is called resonance frequency. So when frequency is same, so time period of the motion of charged particle all along the days and time period of alternating current become same. So after half time period, when the charged particle just changes its course of motion, the electric field of AC oscillator also changes, and it is now along the direction of motion of the charged particle. So the velocity of charged particle and electric field's direction exactly matches each time Because when charged particle changes course after half time period, electric field also changes. So it accelerates the charged particle. Was there electric field opposite to velocity? The velocity would be reduced. So each time charged particle is accelerated, each time its velocity is increased, and with increase in velocity, radius goes on increasing the spiral path. You can see, due to these things, the charged particle take a spiral path. This path is called. And after gaining very high velocity, very high energy, the charged particle is ejected from this exit port, and the charged particle is having very high velocity. So this is about a cyclotron which accelerates a charged particle to very high